One of my direct subordinates, one of my guys that worked for me, he would call me up or pull me aside with some major problem, some issue that was going on, and he'd say, "Boss, we got this and that and the other thing," and I'd look at him and I'd say, "Good." And finally one day he was telling me about some issue that he was having, some problem, and he said, "I already know what you're gonna say."
What are you going to say?
I said, "Well, what am I gonna say?" He said, "You're gonna say good."
Oh.
He said, "That's what you always say. When something is wrong and going bad, you always just look at me and say good." And I said, "Well, yeah. When things are going bad, there's going to be some good that's going to come from it."
True. Yeah.
Didn't get the new high-speed gear we wanted? Good.
Good.
Didn't get promoted?
Good.
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 More time to get better.
More time to get better.
Oh, mission got canceled? Good. We can focus on the other one. Didn't get funded. Didn't get the job you wanted.
Didn't get the job.
Got injured. Sprained my ankle. Got tapped out? Good.
Good.
Got beat?
Good.
You learned.
You learned.
Unexpected problems?
Unexpected problems?
Good.
Good.
We have the opportunity to figure out a solution.
Let's figure out a solution.
That's it.
That's it.
When things are going bad, don't get all bummed out.
Don't get bummed out.
Startled. Don't get frustrated.
Startled. Don't get frustrated. Yeah.
If you can say the word good,
Good. Good.
guess what?
Guess what?
It means you're still alive.
You're alive.
It means you're still breathing.
Ooh.
And if you're still breathing,
Ooh.
well then hell, you still got some fight left in you.
I got some fight.
So get up, dust off, reload,
Reload.
recalibrate,
Recalibrate.
re-engage,
Re-engage.
and go out on the attack.
Alright guys, welcome to lesson number 7 of finance and recursion. So today we're looking at analyzing reducing balance loans. So reducing balance loans with recurrence relations. And our goal today is to be able to fill out an amortisation table and to analyze reducing balance loans. So there's a couple of new words here. Amortisation table and reducing balance loans. So those are the two things that by the end of today's lesson you should be able to understand. So let's see if we haven't forgotten all of the things from last lesson. So here we have to try to choose the best home loan. I'm going to give you guys time to pause it and do it now. Okay, so if we're choosing the best home loan, since we are the borrowers, we are looking for the lowest rate. Now, we have all these different nominal rates, but we also have different compounding periods, which means we have to find the lowest effective rate if we want to compare these different home loans. So what we do is we find the effective rate for each of them. EFF 3.49, so this is what you type into your calculator, compounded fortnightly, so there's 26 fortnights a year, and you end up getting, let's go, 3.49, 26, and you get 3.549. So 3.549, so, is that right? Yeah, it's 549. Okay, and we do that for all the rest of these. Okay, so now that we've done all of the effective rates, we can see that the lowest one is actually this one. So option C, our 3.5% per annum compounded annually, is our best rate out of these four. Now, I would ask you guys to have a look. Both A and B had a lower nominal rate than option C. It's 3.49 and 3.45 respectively. But they each had a lower effective rate, or higher effective rate, sorry, than option C's effective rate. So you know that option C is the cheapest one for you if you're choosing it as a home loan. All right, so a reducing balance loan is one where you accrue compound interest on the loan. So say you borrow an amount of money for a house, for example, or for a car, and you're paying off that loan with regular payments. So these are pretty common types of loans. Personal loans and home loans are very good examples. The recurrence relation for reducing balance loans is this. Vn plus 1 equals R Vn minus D. So now we're using both R and D in our recurrence relation. Something else we also always need is V0 equals our principal. So how much we started with. And I would implore you guys to right now go to your notes and write this formula down in your arithmetic geometric models. It's arithmetic and geometric because we both have the arithmetic term, which is the D, and the geometric term, which is the R. So we have both of those. So far we've only either used R or only D. Now we're using both. Now we're ready for the big leagues. So, an amortization table. We have different types of amortization. The word amortizing pretty much means that the value of whatever loan or investment that you have eventually gets drawn down until it's zero. So it's the act of the loan or investment going from some value, let's say it's 100,000, and then you take out 1,000 each time, and then it goes down to zero. So that's amortizing is going down to zero. An amortizing loan is paid back with periodic payments. An amortizing investment is exhausted by regular withdrawals. So in both cases, they both go down to zero, except in one of them, in the loan, you're paying out until it goes to zero. You're paying it down until it goes to zero. And then for an investment, you're taking money out until it goes to zero. Amortization of reducing balance loans tracks the distribution of each periodic payment in terms of the interest paid. So that's where you have that periodic payment. You're going to be earning interest on how much money is in that loan still. So say you've borrowed some money to buy a car or a house, that money accrues interest. When you pay back some of the money, you're going to be paying back some of the interest and some of the original loan. So that's what we're talking about in that amortization. And then amortization of an annuity, so that's where you're withdrawing money from some investment that you've made. That's going to earn interest, so you're going to be making interest on that investment, and you're going to be withdrawing a bit of interest, but then also a bit of your principal that you originally put in there. An amortization table, therefore, shows how the payment reduces the balance and also reduces the interest. So let's have a look at an amortization table. So what we've got here is we're starting off with a balance of 1,000. So this is in n equals 0. We're starting off with a balance of 1,000, and we want to pay off that balance until we get down to zero. So we want to amortize this balance of 1,000. So we've borrowed 1,000, we want to pay it off. The way we're going to do that is we're going to pay $257.85 every month for 4 months. Now each month we're also adding interest of 1.25%. So this balance will go up by 1.25% every month. But this payment will reduce that balance. So we've got two things working against each other. We've got interest going upwards and the payment bringing it all downwards. So if we look at what's happening between $754.65 to $506.23, we start with $754.65. We add 1.25% interest, so it goes up $9.43. Now we make this payment. This payment, it stays the same each time. Don't worry about this thing. We'll worry about why it's different later. So $257.85. You pay firstly with that $257.85. You have to pay the interest first. Then you reduce the amount of principal that you've got in your loan. And then you find that the new balance is $506.23. So that's how it goes from $754.65 down to $506.23. The same thing is happening between here and here. It goes up 1.25%, but it reduces by the payment minus whatever the interest is. And that's this principal reduction. So you should see the amount of interest getting paid is getting lower and lower each month because the balance of the loan is getting lower and lower each month. So the amount of interest that it makes or that it puts on is lower and lower. Whereas the principal reduction, so how much this is going down by each month, is getting higher and higher. That's because we're paying less interest. But our payment amount is staying the same. Now, this little star here is just indicating that we've got a payment, the final payment, being 4 cents higher than the previous payments. Now, the reason for that is that we want a payment whereby the final balance is exactly zero. If we hadn't added the 4 cents here, we would have had a final balance of 0.04 or 4 cents. So we instead knew that we had to make this final payment $257.89 rather than 85 cents. So I know there's a lot there, but if you go through it a couple of times, it'll make a bit more sense to you, and notice that every line is just doing the same thing over and over again. All of the explanation are in these 2 slides. So these 6 steps are as follows. And what I wanted to show is this graph. It shows how the amount of interest paid for each payment goes down. It's the blue dots. And the amount of principal paid for each payment goes up. That's the red dots. So it looks something like this. But if you get this amount and add this amount, you end up getting the same amount each time. So it's going to be around here, $257.85. So if you add the blue dot and the red dot, you should get up to this little red line that I've drawn. So let's have a look at an example. Alyssa borrows $1,000 at an interest rate of 15% per annum, compounding monthly. She will repay the loan by making 4 monthly repayments of $257.85. So that is the situation that we were dealing with just then, except we have here 15% per annum, which ends up being 15 divided by 12, which is 1.25% per month. So that's why we were dealing with 1.25%. She will repay the loan by making those payments, $257.85, that's what we had before. Construct a recurrence relation to model this loan. All right, so this is our monthly payment. This is the payment that's happening. It's the same payment every month. So that's going to be our D. 15% per annum is our per annum rate, but we know that 1.25% is our per month rate. So that means our R is going to be equal to 1 plus 1.25, 1.25 divided by 100, because that's our little r. Our little r is 1.25, which is 1.0125. Therefore, our recurrence relation is V0 equals 1000, Vn plus 1 equals 1.0125 times Vn minus $257.85. So we've just modeled this amortization table as this recurrence relation. You're starting off with a value of 1000. It goes up by 1.25% each month. but then it decreases by this payment, $257.85 every month as well. Use your calculator to determine recursively the balance of the loan after Alyssa has made each of the 4 payments. Let's go into our calculator. So we're starting with 1,000. So that's our starting value. Now we know with that value, it's multiplying by 1.0125, but then it's getting $257.85 subtracted each time. So after the first payment, we should be getting that 754 value. So it goes on 754, $506.23, $254.71, and just as I said before, we're left with 4 cents because we didn't change this final payment to be 89 cents instead. That's okay. We've got the value of the loan after 3 months. All 4 months, but after those first 3 months, we've got them correct. So that's how we do it, and that's what we expect to get. What's the balance of the loan after she's made 2 payments? So after first payment, it's $754.65. After the second one, it's $506.23. So that is the balance still owed after 2 payments. Is the loan fully paid out after 4 payments? If not, how much will the last payment have to be? So just as we saw before, since there's 4 cents left, this last payment needs to be 4 cents more than the other payments. So the normal payments are $287.85, add 4 cents, $287.89. So that's why our previous amortization table looked like that. And this is what we saw before. And what we were saying in that last step is we want to change this to a 9, and then this becomes a 0. Okay, let's have a look at this example. So we've got a business borrowing 10 grand at a rate of 8% per annum. This loan is paid by making 4 quarterly payments of $2,626.20. The amortization table for this loan is shown below. Note that the final payment, this one here, has been altered so that the final balance is 0. All right. So the first question, if we look at the next page, is to determine the quarterly interest rate. So let's have a look at our per annum rate. This is our R. Our quarterly rate, if this is our per annum rate, then our quarterly is going to be 8 divided by 4 equals 2% per quarter. So we just divided by the number of quarters in a year, which is 4. So that means between each of these periods, it's going up by 2%, since each of these periods is 1 quarter. All right, so if we want to find the amount of interest that's accrued after the first payment, we have to figure out 2% of 10 grand, because that's how much interest is going to be earned on this, or how much interest is going to go up by on this loan. So 2% of 10,000 is $200. So since our interest is $200 and our payment is $2,626.20, the amount that our principal goes down by, so this goes down by, is going to be this minus that. So that minus payment minus interest equals $2,426.20. Cool? Now this is going to be 10,000 minus that. So 10,000 minus $2,426.20 should give us this, and you can double check that with your calculator. All right, let's fill in this box now. What is the amount of principal that's going to be reduced for the second payment? Well, we know firstly that we've already had the interest calculated for us. We know that this value here is just going to be the payment minus the interest. So 2626.2 minus 151.48 equals, and we'll chuck that in the calculator, $2,474.72. Cool. And then again, this value minus this value equals this value. All right, let's figure out what this box is going to be. $5,099.08. So this is the balance from the previous period minus the amount of principal that it's going to go down by is going to be what goes into this box. And we should have this box equaling this entry here, because since this is the principal reduction, whatever this principal is going to be minus this has to equal 0. Therefore, this one has to equal this one. But let's double check. We know that this value is going to be the previous value minus the principal reduction. So $5,099.08 minus $2,524.22. $5,099.08 minus $2,524.22 equals $2,574.86. Perfect. $2,574.86. So that's just a double check. Okay, finally, this principal reduction, we should have a total of $10,000 here, but the amount of interest paid should be equal to the sum of this column. So if we add all the amounts of interest, then we'll get the total interest paid. So if we do 200 plus 151.48, plus 101.98 plus $51.50, we should get $504.96. So, in conclusion, the balance of the loan has gone down from $10,000 to 0. We've reduced the principal by $10,000. We've also paid an extra $504.96 in interest while we've paid off the loan. So hopefully that makes sense as to what an amortization table is. Please do the practice questions. So these are Edrolo 5G. So please do all these questions. It's Edrolo 5G. In the unit plan, it says that we're going to be doing questions 1 to 8. That we're going to be doing them in 2 separate lessons. So try questions 1 to 8 first, and then maybe give it a rest, have a day, and the next day do questions 9 to 19. All right, good luck. And remember, good.
Re-engage.
Re-engage.
Go